The second type of variation problems we're going to look at are called inverse variation. And we read this as y varies inversely as x, or y is inversely proportional to x. And remember, when we see the word varies, that will be equals k. And inversely proportional, that's just a different way to word varies. So that's where we'll put equals the constant as well. So the setup for inverse variation is y equals our constant k divided by x. So you remember directly was y equals k times x. So I think of that one as direct variation. We have x directly beside the k. And when it's inversely sounds like inverting, right? So for inversely, the x will go under the k. All right? So let's look at a problem. If y varies inversely as x, so we know varies is where we're going to put k. So we have y varies inversely means it goes to the denominator as x. Then just like with the directly problems, they're going to give me a value for y and x, and I can plug those in. So if I have y equals k over x, I'm going to replace y with 12 and replace the x with a 3. And if we want to solve that for k, you notice this is a rational equation now, right? So my LCD, my denominators are 1 and 3. So my LCD is just going to be 3. So I'm going to multiply both sides by 3. And on the left-hand side, there's nothing in the denominator, so we can't cancel anything. So 3 times 12 is 36. And on the right-hand side, we do have a 3 in the numerator and the denominator, so those can cancel. And now that leaves me with k. So this is the first part of the answer. That's my constant of variation. K is 36. So then to write the variation equation, we just go back to the original, and we're going to substitute in now what we know for k. So k is 36. So my variation equation is y equals 36 over x. All right, number 2 is very similar. I have y varies inversely. So y varies inversely means it's going to go to the denominator. What's varying inversely is the square root of x. So in the denominator, we'll put square root of x. Then it's going to give me values for x and y. So if y is 3.2, so I'm going to replace y with 3.2. And x is 16, so that's going to give me square root of 16. Then we want to find the constant of variation k and the variation equation. So we can simplify this a little, right? We know that the square root of 16 is 4. And now, just like the last problem we did, we're back to a rational equation. My LCD this time is going to be 4. So I'll multiply both sides of the equation by 4. So I put into the calculator 4 times 3.2. I got 12.8. And on the right hand side, we have a 4 in the numerator and the denominator, so those can cancel, and that leaves me with k. So that's our constant of variation. So then to write the variation equation, all we do is substitute the k that we just found into that original equation. So this is my variation equation. So I'm not sure if I explained that for the direct variation or not, but these first couple of problems that we did, what we're doing with those is just finding a general variation equation. So once I get to here and here, now I can find out how the y and the x relate to each other for any given x and y situation. So then when we get to a question like number 3, this is actually an application where we're actually using the variation equation and we're actually given the information that we need to do to solve one. So let's see what this one says. We have the time required to prepare food for a wedding rehearsal. So I'm going to say time is t, is inversely proportional. And remember we said inversely proportional, that's just another way to say varies. So this is where my equals k is going to go. What is varying inversely is the number of cooks working to prepare the dinner. So I'm going to call this C. So our equation, we have the time required varies inversely as the number of cooks. So then if it takes 6 hours, so that's my T, right? And 2 cooks. So that information is going to allow me to figure out what K is. So first, I'm going to use my equation to figure out what my constant of proportionality is. So I'm going to replace T with 6 and replace C with 2. So we have a rational equation. My LCD is 2. So I'm going to multiply each side by 2. So on the left hand side, 2 times 6 is 12. And on the right hand side, my common factor of 2 is going to cancel. And I'm left with K equals 12. So now that I know my constant of proportionality, we can do what we did in those first problems, and I can say now I know T equals 12 over C. And this is what I was talking about. Now that we have that general equation, we can actually use that to now solve for any situation where I'm given what T and C are. And that's what the next part is. How long will it take? So we're looking for T, right? 3 cooks to prepare the dinner. So now we're looking for T. And this time we have 3 cooks. So I'll place the C with a 3. And that gives me 4. So in this given situation, if there are 3 cooks preparing the dinner, it's going to take 4 hours. All right. We have one more type, and this one we won't end up using a whole lot, but I want you to see it because it is another type of variation that comes up. This one is joint variation, and it works like directly, except what you might think of for the word joint. there's going to be more than one variable that's varying directly. So this one says y varies jointly as x and z. So that's the difference, is it varies with two different variables. When I see varies, that's still going to be my equals k. And just like the others, if it gives the other wording, y is jointly proportional to x times z, that's just another way to write varies again, and it would also be the equals k. So the format of this one is y varies or equals. We have the constant k, and it's going to multiply times two variables, x and z. So this first one, it says y varies. So y equals k. Jointly means it's going to multiply as x and z. So you don't have to write the multiplication signs. It's going to be y equals kxz. And then if we're given that y is 16, x is 4, and z is 2, we can solve for k again. So I'm going to replace y with 16. I'm going to replace x with 4 and replace z with 2. And now we're just going to simplify. So on the right hand side, we're going to have 2 times 4 is 8k. Then we can divide both sides by 8. And I get k equals 2. So that's the first part. We've found the constant of variation. So now to write the variation equation, all we're going to do is substitute in the value we found for k. So we get y equals 2xz.